Okay, so we're still at this section here, the CDK framework. Started introducing it the last AG, so I'm just going to pick up the story from there. Some people, based on some conversations I've had on Slack, some people have started this lab uh, late last week, I guess, which is fine, but really, it's not really until I complete this set of slides that that lab would make a whole lot of sense. Uh, let's keep going on the slides. So I've introduced these slides the last day. The topic we're looking at is the technology we're looking at is the AWS CDK framework. And this framework is targeting an area called infrastructure as code. And the idea of infrastructure as code is that we'd like to be able to provision resources on the AWS cloud, provision them in an automated way using general purpose programming languages. In our case, we're going to be using TypeScript, but we could use a number of other languages as an alternative. Um, and I talked about the various benefits of being able to provision infrastructure in an automated way using code. So if we fast forward to here, I guess is roughly where I left off. So the last day, again, you may remember, I was giving you the history of this infrastructure as code idea. And this kind of this onion kind of layered image describes the evolution. So initially, what the AWS people did was they provided web API interfaces to the various services that they offer, like the EC2 service, the IAM service, the S3 service, etc., etc. So by providing a web API interface to them, that means we could communicate with them over HTTP, but rather than interacting with them using raw HTTP, the AWS people also provided an SDK, a software development kit, which we could then use within our own programming uh, projects. Okay, so we could write a programming script using, again, a variety of languages, although initially the dominant language would have been Python. So we could write a Python script which used the SDK, the Python SDK, for the purpose of sending requests to a particular to a particular AWS service for the purpose of creating some resource within that service. Again, for example, create an EC2 instance, create an IAM role, etc., etc. Now, that was fine, but it had many defects or deficiencies, and I talked about those the last day. What the AWS people then did was, as a way of overcoming the problems with that raw kind of scripting approach, was they provided a new service which they called the Cloud Formation Service. The generic category for this service is what's referred to as a resource provisioning engine, because you must remember AWS are not the only cloud providers. We know of the others, and they also have their resource provisioning engine service. But in the case of AWS, it was called CloudFormation. What CloudFormation did was essentially it took care of communicating via the SDK to the web API for us. So now what we had to do as developers were we no longer had to write our own raw Python scripts. We now described the infrastructure that we required using a templating language, JSON or YAML. We provided that template we uploaded it essentially to the CloudFormation service, and it took care of getting the various other AWS services to create our infrastructure for us. But critically, if we then wanted to change some configuration of that infrastructure, or maybe add a new piece of additional infrastructure, or remove a piece of infrastructure from the overall set of resources that we wanted created, then all we had to do was change the template that we had written, updated, in other words, upload that updated template to the CloudFormation service. And because it knew what the current state of our infrastructure was, it would simply work out what changes needed to be made to our infrastructure, and it would communicate that via the SDK and Web API to the relevant resources to carry out those changes. So the term we use for all of that is state management. The CloudFormation service was able to manage the state of our infrastructure. Okay, we had to tell it what the new state should be, but the transitioning from the new state, the transitioning from the current state to the new state, that's not a straightforward transition. The CloudFormation service, however, works out the various steps that need to be carried out in order to execute that transition, and the order in which those steps need to be performed, because the order is invariably very important. So it took care of all of that. Previously, we had to worry about that in our raw scripts. The downside of CloudFormation is you were now having to write pretty long template documents to describe the infrastructure requirements that you had. That introduced or brought about the next generation of infrastructure as code technologies, which, for example, the CDK framework is one example of that next generation. I'm calling it the third generation. Some documentation that you will read actually only refers to it as the second generation, but that meaning that CloudFormation was the first generation. But with this new generation, this third generation, we no longer had to write our templates using JSON or YAML. We now could actually describe the infrastructure that we needed using a general purpose programming language. Okay, so that's roughly where we left off. Right, so the particular technology or third generation infrastructure as code technology that we will look at is the CDK framework, which is specifically for AWS. There are other third generation frameworks that you can use, and you can target any of the other cloud providers, which are obviously, they would be slightly better again, but the CDK is the one that we're going to look at. And so when you're developing in using the CDK framework, we still talk about applications. So we talk about a CDK application. However, a CDK application is only interested in creating infrastructure. Doesn't really have any associated functionality of the application. So a CDK application, technically or structurally, what it's comprised of is what are called stacks. So an application could comprise of many stacks. Now, in our case, in all of our cases, there will only be one stack per application. Stack actually is a term that was used or that is used by the CloudFormation service. So we're borrowing that term. A stack is comprised of what are called constructs. And a construct is comprised of resources. Resources are the kind of lowest level of infrastructure that you might want to have created for you. Okay. So a resource is a term that we would use when we're talking about infrastructure down at the lowest level. A construct is really an abstraction of that. Construct really will materialize as a class, as we'll see. Um, so that's okay. And then a stack is comprised of many constructs. So that's just the terminology that we use with the CDK. And it's the same similar terminology actually with the other third generation frameworks. The graph then kind of gives you a kind of visual representation of the kind of hierarchy that's going on here. So we've got an application comprised of many stacks. A stack is comprised of constructs, and then a construct. When we execute a construct, it will result in the creation of a number of resources uh, on the AWS cloud. Okay, this is the code, if you like, that we write, and then when we execute that code, what happens is our infrastructure is created ultimately. Okay. The one of the main benefits of using something like the CDK framework is it improves the developer's productivity. Prior to frameworks like the CDK, we had to write those templates that I was talking about, which were quite verbose. But when we use the CDK framework, there's far less syntax that we have to write, and therefore the developer is more productive. Just one simple example here. This is a simple it's a simple stack for creating a single EC2 instance. Okay, it's roughly 12 lines of code. When that gets converted into a CloudFormation template, it results in about 150 lines of code. So this is what we would have had to write if we didn't have the CDK framework available to us. In this image, I'm just showing you the kind of the execution flow when we're using the CDK framework. So here's you, the developer. You write your infrastructure code using whatever language you desire, in our case, TypeScript. That TypeScript code is then, we execute it. The TypeScript code is part of the CDK. Well, okay, we execute it via the CDK framework. Let's put it that way. The CDK framework outputs the CloudFormation template. It also uploads that template to the CloudFormation service. And then the CloudFormation service does what it always did, okay, which is it takes the template and it talks to the various services, the various CloudFormation services like EC2, IAM, S3. It communicates with them over using the SDK. And the service then, in response to the requests that are made by CloudFormation, the service creates the particular piece of infrastructure that it has it has been asked to create. Yeah. And so whatever these are, this looks like it's a database. So maybe this is the DynamoDB service. These symbols aren't really important. Just generically, these are resources. So it's the lowest level of granularity from AWS's infrastructure perspective. So that's the flow, that's the execution flow. And as before, if I want to change my infrastructure down here, I make the change to my code. You can think of the code as describing the infrastructure that you require. You don't have to worry about the order in which things are created. Okay, so I change my code. Again, I get the CDK framework to generate a new CloudFormation template. This template will have some differences relative to its predecessor, but all we've got to do is upload this updated template to CloudFormation, and it will work out what has changed since the previous template, and it will make the relevant calls to the services, asking them to carry out the changes to the resources that were created, or maybe delete a resource, or maybe create a completely new resource. In terms of you, what do you do from the kind of from the command line to get things going? So the first command is just the CDK init command. So you want to create a blank CDK application. You do have to tell it which particular language you're going to use. Now that command will essentially scaffold a shell CDK application, and we'll look at the structure of that in a second. Then we actually write our infrastructure code. So we make changes to particular files that were created in the template project, in the skeleton project that was created from the first command. We write our infrastructure code in TypeScript in our case. Now, this command is optional, but if you do type this command, and we type all these commands now from the base folder of the application that we've created up here, the CDK sint command will create or generate, sorry, the CloudFormation template, and you can look at that on your local file system. The CDK deploy command, actually, I very rarely use the CDK sint command. I always use the CDK deploy command, and what the CDK deploy command does is, if the template has not already been created, it will create the CloudFormation template, upload it to the CloudFormation service, and the CloudFormation service does its thing, okay, as we saw from the previous slide. Maybe then, when we're happy that the infrastructure has been created, and we could check that maybe using the management console, we then maybe want to make some changes to our infrastructure. So we go back and make changes to our code. And we simply type the CDK deploy command again. There shouldn't be a dot there, that's an error. The CDK deploy command will again generate a new template, a new CloudFormation template, upload it to the CloudFormation service, and the CloudFormation service will affect the changes that we have described in our code, in our TypeScript code. And so you keep on sort of in this circle here of changing your infrastructure, redeploy, change your infrastructure, redeploy, and eventually you're happy that the infrastructure is exactly the way you want it to be, and now your application is up and running, if you like. If you want to essentially destroy all of the infrastructure, then the CDK destroy command, simple command, will take care of all of that for you. When you type the CDK destroy command from the command line, the CDK framework will essentially send a request to the CloudFormation service. When I use CF here, I mean CloudFormation, telling the CloudFormation service to essentially destroy the stacks that it has created for your application. So go back to it. So when we type this command here, it creates a skeleton CDK project on your file system, and this is what it looks like. Now, essentially, this is the main part here. In the lib folder is where we put our infrastructure code. And you have one file in this folder per stack. Now, typically, as I said, we would only have one stack in an application, so there will just be one file. So this is the file where I put my code that is describing the infrastructure that I want to have created for me. This file up here, you rarely need to go near it. It's generated for you. But what happens actually up here is it creates an empty CDK app, and then it adds the stack to that app. I'll probably show you the code in a moment. The rest really you don't need to worry about. But you can see down here that because I'm using TypeScript, this is essentially a node project, if you like. You can see here it has a package.json. Um, it has a TypeScript configuration file because I'm using TypeScript. Okay, there is the possibility of testing your infrastructure, but that's a little bit complicated and not very stable, so we won't go near that. So we will find ourselves almost exclusively editing this file here. And every time we edit it and make a change, if I go back to the previous slide, we just type the CDK deploy command again to get CloudFormation to carry out the necessary changes to our infrastructure. If I just go back again, sorry, to here. So I said, sorry, here, an application is comprised of stack, and a stack is comprised of constructs. Okay. Now it turns out that there are 3 levels of constructs. That's what I'm talking about here. There are what are called L1 constructs, L2 constructs, and L3 constructs. This is just specific now to the CDK framework. Other competitor frameworks don't necessarily use the term constructs, and they don't talk about L1, L2, and L3. So this is specific to the CDK framework. 99% of the time, we will be using L2 constructs. So when we create an instance of an L2 construct, that will eventually result in the creation of a number of resources, infrastructure resources up in the cloud. So I'm saying here that there's a one-to-many relationship between a construct and a CloudFormation resource. Okay, CloudFormation resource is a piece of infrastructure. So by just creating one instance of a particular construct, L2 construct, sorry, and there are a number of L2 constructs, but by instantiating one instance of an L2 construct, when eventually that code gets executed, it will result in the creation of a number, potentially, a number of CloudFormation resources or infrastructure resources. Not a number of copies of the same resource now, different resources. And that's one of the benefits really of using this third generation, that a small bit of code can result in the creation of a number of infrastructure resources or CloudFormation resources. L3 constructs they usually kind of implement what are called patterns, infrastructure patterns. So again, there's a one-to-many relationship, but we won't be using any L3 constructs. In the case of L1 constructs, for each L1 construct that you have in your code, it will result in just the creation of one piece of infrastructure, one infrastructure resource. So there isn't a whole lot to be gained by using these L1 constructs, but maybe sometimes you do have to actually use an L1 construct. As I said, we'll mainly be using L2s. Now, of course, it's not until you demonstrate this stuff that it starts to make sense, I hope. So what I'm showing you here is a very simple CDK project, and it has the structure that I talked about, that I showed you on the slides. So here's our lib folder with our stack file. Okay, so I guess we could just we'll look at the stack file in a moment. In my package.json, surprise, surprise, I obviously, because this project is a TypeScript project, I need the TypeScript language. I need TS Node because that's actually being used behind the scenes. Here's my CDK framework. Here's the actual kind of the library part that is separate from the framework. Okay, so there's stuff in here that we would expect given that we're using the CDK framework. And here's the stack file. So maybe we could, okay, we've got a couple of imports. In particular, we're importing one part of the CDK library, which is the part that supports infrastructure related to the EC2 service. Okay, so structurally, our code, it looks like I'm creating a class. I can give the class any name I want to. So that's the name I've given it. And this class extends a superclass, which is taken from the framework, and it's extending the stack class. So straight away, we could work out, well, it looks like here that we're creating a class that is representing a stack. Yeah. Here's the constructor for this class. Now, what you will notice is, and we will be doing this right throughout this module, we will be creating stacks in this way. So a stack is implemented as a class. What you will notice is that we will only ever be implementing the constructor for that class, for our stack class. We won't necessarily have private methods. There may be one example where we have private methods. We'll never have a public method. Okay, so it all happens really in the constructor of your stack class. That's where you describe the infrastructure. And okay, if I look at the detail then, okay, in this particular example, okay, the very first line here is a slightly odd one, but all I'm doing in the line that I've highlighted there is I'm grabbing the VPC that has been created, the default VPC, Virtual Private Cloud instance that was created when you created your AWS account. When anybody creates an AWS account, the AWS platform will create what's called a virtual private cloud for your account. Okay, and you can create other VPCs subsequently, but we will never need to do that. But there is a default VPC. So I'm just grabbing the reference to the VPC that is associated with my AWS account. And this is the kind of proper infrastructure code, if you like, because the very first line is slightly non-standard, I guess. And so what I'm doing here is my purpose is to create. I want to have an EC2 instance created for me. Okay, so I'm instantiating an instance of EC2.instance. EC2 is what I imported up here. So it looks like I want the infrastructure that I want to, or one particular part of the infrastructure that I want to have created is an EC2 instance. And if I look at the arguments that I'm passing to this this class constructor, I'm passing this. Now, when you create, sorry, just to go back to our whole area of constructs, this now is an example of an L2 construct. So not only will, when this is executed, not only will it create an EC2 instance, but it will create some other infrastructure resources as well, like IAM roles. It'll create a default security group and some other resources as well. But they will happen automatically. And that's the nice aspect of these L2 constructs. We don't have to specify every single part of the infrastructure that we want created. The framework will work out what other parts of infrastructure need to be created if you haven't specified them. So this is going to create an EC2 instance. Now you must attach or associate that instance with a stack, even though you might think, well, why does it not automatically assume that it's part of this stack here? And the answer is no. Okay. So this argument that I'm passing is essentially referring to the stack. So I want to associate the EC2 instance that is going to be created. I want to associate it with the current stack, if you like. The second argument is just an identifier, an arbitrary identifier that you want to have, or label, if you like, that you want to attach to the EC2 instance. And then the rest, which is this, let me just collapse that. All of this then is the configuration that I want to have associated with this EC2 instance. Now, there are many parts to the configuration. You can leave many of them out, and then they assume default values. If we were writing CloudFormation templates, then we would have to specify each particular part of the configuration, and that's why the templates are so long-winded. But with this CloudFormation framework, we can just specify the parts that we want to take on a value other than the default. Now, and even some of the values that I've put in here that I've initialized, I could probably have left them out and it would still work fine. We don't need to go through, what are all the different options available to us for two reasons. One, wouldn't be terribly interesting. And two, we're not going to be using EC2 from here on in anyway. But just to step through it, it looks like what I'm doing here is I'm attaching these, or I want the EC2 instance to be attached to the virtual private cloud that I've grabbed a reference to here. That's what's happening in this line. And then the rest here is clearly describing some characteristics of the EC2 instance, like what AMI do I want to have associated with the instance, what operating system do I want to have installed. So it looks like I want what's called the T2 micro, a T2 micro image attached to this EC2. Now, for those of you that haven't done any AWS, T2 micro probably doesn't mean anything, and I'm not going to get into the detail of it again, because as I've already said, we're not going to be using EC2 after this week, really. So all I'm doing here is describing essentially the different layers. And EC2, of course, as you know, is a VM, a virtual machine. So I'm just describing what operating system, etc., and default kind of libraries that I want to have installed on that EC2 virtual machine. That's all that's going on there. And that's it, right? That's my stack. I have nothing else. I'll bring this stuff enable this stuff in a little while. So my stack is just comprised of one EC2 instance, although, as I said, there will be some other pieces of low-level infrastructure created as well for me. If I look at this file here, all I'm doing here is I am creating an empty CDK app. And then what I'm doing here is I am attaching my stack to that app, because we said an app is comprised of many stacks. So I'm just attaching one stack, and the stack that I'm attaching to the app is the stack that we've just been looking at. And that's all that's happening here. Okay. You don't actually have to specify, that's my AWS account ID. You don't actually have to do that. It would work it out anyway from my command line here. And you actually don't have to specify the region either. I am putting them in here, but I could have left this entire line out and it would still work, because I have the AWS CLI configured locally, and in my local configuration, my default region is EUS1. And of course, this is my account, my AWS account ID. Now, I want to run this CDK app, and by run, we mean we want the infrastructure provisioned. So it's simply a case of, if I go CDK deploy, when I hit return, the CDK framework will take my code. It will start actually here, and then it will pull in the stack file, and it will consume all of that. It will generate the the CloudFormation template, and it'll put it into this folder here. Now this folder already exists because I've already done a CDK deploy. But if we drill down into the folder actually, and just pull this over a little bit. There's the CDK, sorry, mixing them up. This is the CloudFormation template that was generated by the framework for the code that I've written. And if we just open it up, we certainly won't look through it, but this is your CloudFormation template. In this case, it's in JSON format, but we could have specified it, asked it to generate in YAML. And it's pretty, not that long, I guess, but still difficult stuff to kind of write. But of course, that's generated for us, so we don't need to look at it. Let's do a CDK deploy, although maybe just before I do it, if I switch over to my account on the cloud, and if I go into the EC2 service, now I do have one EC2 instance already within my account. This is actually the EC2 instance that we used in the Agile module in the previous semester, but you can see here that the EC2 instance is stopped. So effectively, I don't have any running EC2 instances. And if I do go back to here and hit return, and it's asking me, am I okay now to go ahead and do the deployment? I say yes. Now, it's not great from a lecturing point of view to do these deployments at lecture time because sometimes they can be a little bit slow, but I will persist with it in this case. And you can see what's actually happening now here is that the CloudFormation service is responding back to me and giving me updates on what's happening. You can see it's kind of creating various parts of it's creating various infrastructure resources as it's executing the CloudFormation template that has been uploaded to it. And there's a lot of stuff being created. If you can see, look, it's creating an IAM instance. I had nothing about IAM in my stack, but that's an example of these additional resources that are created for me by CloudFormation. It's not just an EC2 instance, it's creating some other resources as well. Here it's not creating an EC2 instance, it's creating an EC2 security group, which is another example of a kind of low-level piece of infrastructure. And maybe if I switch over to the management console, and if I actually bring up the CloudFormation service, we can kind of see what's happening here's the stack. This is the stack that it has created for me. CloudFormation deals in stacks, whereas CDK, we talk about apps, but of course the CDK app is comprised of stacks, and the CDK app that I'm deploying only has one stack. That's why there's only one stack here related to my app. If there were multiple stacks, we'd see them all here. And if we go into the stack, and if we go into the events, It's just you can actually see what's happening at the cloud formation level. It's talking to the various services. Essentially, what I'm kind of showing you here is mirrored by what I'm showing you here. Yeah. Because the cloud formation service is keeping my terminal updated with what it's doing for me. So it's still working away, and eventually it will tell me that the stack has been uh, completed successfully, hopefully. Yeah, it's finished now. Uh, and that should mean that finished means that it has created the entire stack for me. And if I stay in the CloudFormation service, you can see here now that the stack has, well, it's saying still in progress. Let me do a refresh. Okay, you can see that the creation is completed. And the most uh, relevant part or the most relevant resource, I suppose, that I'm interested in is in the EC2 instance. And if I go into the EC2 service, or the management console, sorry, and bring up instances, then lo and behold, here's an instance that's currently in the running state. And this is the instance that it has created for me. Yeah, the name it gave to it, CDK demo stack. Well, if I just go into it actually, CDK demo stack, blah, blah, blah. Let me see, does that tally with what I said back here in the code? If I go into my lib folder, okay, it's not EC2 instance. Maybe EC2 instance is actually named. It's used by the is used by the CDK rather than. Is there any evidence of that here? Oh, there it is. There, look, EC2 instance. So it got that from my TypeScript code. The full name of my EC2 instance is the name that I've decided to give it, concatenated with the name of the stack that it belongs to. That's just a decision that the Cloud Formation service made, and it makes sense. Okay, so that's demo 101. Now let's supposing I want to change the state of my stack. I want to make some changes to it. And a simple illustration of that might be, again, the next part now assumes that you know a little bit about EC2. But if I look at the configuration of this EC2 instance, and we can see the configuration down here. And if I go into the security part, and if I access the security group that has been defined for my EC2 instance, and it's telling me that there are no inbound rules. Inbound rules kind of control what type of HTTP access, well, sorry, not HTTP, TCP IP access, inbound access you are giving to this EC2 instance. Currently, there is essentially no access, so there's no way I can actually um, connect to that EC2 instance. Outbound controls what the EC2 instance can, what kind of TCP communication it can initiate. So it looks like it can make any kind of TCP IP call outwards, okay, but there's no inward calls. So let's supposing I want to change that. I want to add some what EC2 calls inbound rules. So I go back to my code, and here's how I'm going to do it. I need to go into my lib folder, into my stack file. So just for convenience here, this is the code that I'm going to add on. Now, what I'm doing here is I'm creating another L2 construct called the security group construct. You'll notice that all of these constructs, they have the same kind of signature their constructors do, which again is you have to tell, you have to indicate what stack do you want to associate this construct with. And in 99.9% of the cases, you want to associate it with the current stack. So the this refers to the current stack. The second argument is just a custom label or name that I want to give to this particular uh, construct. And the rest then is the configuration for this construct. And of course, the configuration differs depending on the type of construct that you are creating. And we can, some other day, we look at, well, how do I find out what the different configuration settings are for a particular construct? We can deal with that another day. But for this one anyway, I happen to know that there are these two properties. And the way you interpret what I'm trying to do here is, first of all, it looks like I'm also associating this security group construct with the default VPC, and I'm also allowing all output traffic. That's okay. And here I'm actually, I think I'll bring this in as well. It looks like here I want to add an inbound rule to my security group, and the inbound rule is saying open up port 22. Um, Open up port 22 to any kind of any source. Okay, so okay, I've essentially defined a custom security group that I want to have associated with my EC2 instance. Now, I need to link this security group with my EC2 instance though, and that means I've got to go back to here and enable this line for myself. Okay, so in my first deployment, I didn't specify any security group. And so what CloudFormation does is it attaches a default security group to my EC2 instance. Whereas now I want to be more specific. I want to specify particular characteristics of my security group. Now the only reason there's an error here is because this is a variable that is being referred to, but the variable is this one down here. So you can't refer to a variable. This is just simple programming rules. You can't refer to a variable before it's actually declared. So if I just pull all of this code up to before the EC2 instance, let's move it up to here. And my error is now gone. Do I have any other errors? Let's just see. No, no problems. Okay. So in the language that I was using earlier on, I've now carried out a change to my infrastructure requirements. And specifically, it looks like I've added a new construct, which will result in the creation of either one or many new resources. And I've attached that construct to the EC2 construct that I had earlier on. So there are changes, right? But all I've got to do from the CDK point of view is just say CDK deploy. And between the CDK framework and the CloudFormation service, it will work out what changes need to be carried out. It won't destroy my EC2 instance and create it all over again. It will actually carry out some configuration changes to the EC2 instance. So let's hit go. I'll say yes. And we'll notice now that a lot of what's going to be going on here is updates rather than creating. Um, you can see here like it's talking about updating stuff, which makes sense. Sometimes it's creating something new though, and the creating is related to it's gone. Okay, now just let it work its way. Now that was a lot quicker because it didn't have to provision a new EC2 instance. So now if I switch over to the management console and check to see, well, did it actually carry out the changes that I desired? So remember now, if I go back to here, sometimes the management console takes a little bit of time to um, see the changes. So you may need to do a couple of refreshes and reloads. That's okay. So here's my EC2 instance, and if I have it selected, so I'll go down to the security part of the EC2 instance, grab the security group, look at that. And there should be a new inbound rule here, but I think if I just do a refresh, we wanted to open up port 22, you remember? Okay, I need to go back to here. And reselect this. Again, this is just the browser needing to be refreshed, really anything other than that. Just going to do a manual refresh. Okay, are we success? Yeah, so here I'm looking at the inbound rules for my new security group, and here's the rule that I wanted to add. I'm opening up the SSH port, which is TCP port 22, and that's what I indicated in my code. So it looks like the state change has been followed through. And if I wanted to remove that, I could go back to my code again. Now decided I want to close off port 22, for example. So I will just remove this code again. And disassociate that security group. And if I just did a CDK deploy again, and then wait for it to complete and go back to my management console, you would see that it would actually have removed the inbound rule for me. Okay, we won't waste time actually doing it. Right, so I've demonstrated kind of one-on-one example of using the CDK framework. I've demonstrated in the context of creating an EC2 instance, that piece of infrastructure. But as I've said a number of times, there are a number of other infrastructure resources that were created along with the EC2 instance, like an IAM role, a security group, and so on and so forth. And we also then looked at if I want to make a change to my infrastructure, then by just changing the code and do a CDK deploy, then between the CDK framework and the CloudFormation service, it affected those changes for me. Now in the lab, if I just for a moment talk about the lab, The lab is actually far more elaborate in that I get you to create this. I would argue this is a fairly sophisticated piece of infrastructure. Now, again, this kind of assumes that you have done this stuff already, and I'm not too concerned if you're not familiar with this sort of layout here. I've got what's called an application load balancer, which is a piece of infrastructure. I want to have two EC2 instances created. I want those instances to have their own specific security group, and I want them to be managed by what's called an auto scaling group. These are all AWS infrastructure resource kind of concepts. And so I want to set up this fairly elaborate piece of infrastructure, and I give you the code to do it. And I do show you maybe various places that you can look at to confirm that all of the infrastructure has been created. Now, uh, to prove that it works, what you do is if you just open up a browser and when an application load balancer resource is created for you, that application load balancer has a domain name, which is generated by the AWS itself. And if we simply browse to that domain name, what should happen is the request will be sent to one of my EC2 instances. For both of these EC2 instances, I also install the Apache web server. That's all part of the TypeScript code that I write. And the Apache server has a kind of a default home page. And so when you browse to the application load balancer from your browser, that request will be sent to one of these two EC2 instances, to port 80 specifically, and the Apache server will respond with the home page, and that will come back to your browser. And the home page looks something as simple as this. It's just hello world, and this is the domain name of the particular EC2 instance that responded, because it could be one of the two. And so that would prove, if you got that response, that would prove that the entire piece of infrastructure that we have in the image up here has all been deployed properly for us. And as I've said already, it's a fairly elaborate piece of infrastructure. Now, if just for a moment, if I load that CDK project into my VS Code, I want to spend too much time explaining it. Spent very little time explaining it because, again, it's all based on EC2, and we're not that concerned with it. So if I go down to here, here's the stack in this case, and there's a lot more going on in this stack, right? Excuse me. Let's see. Okay, I'm creating a security group there. I'm getting my default. No, I'm actually creating a special VPC for myself, creating a security group, creating my application load balancer, creating okay, I'm configuring my load balancer here. I'm, what this is a, a kind of a boot script for my EC2 instance. Okay. And so, for example, you'd see that let's see, I am installing the Apache web server. I am starting up that web server. And I am creating a piece of HTML, and I'm making this piece of HTML essentially the home page for my Apache server, yeah, because I am writing it to this particular file on my EC2 instance. I'm sorry, I'm writing it to, yeah, to this file on the EC2 instance, and this is the actual path where the Apache server goes looking for its home page. Uh, and there's some other stuff down here as well, okay, which we needn't worry about. Now, having said all of that, some of you will probably get an error when you try and back to my lab. When you browse to the URL associated with the application load balancer, what some of you and maybe many of you will get is an error, and it will be specifically the 502 gateway error. Now, I think what's causing that is the following. It's this little piece of code here. I'm trying to grab the host name of the EC2 instance that this script is running inside. So what you could do is if you simply remove that, so I'm saying just simply make it the following. Sorry now about this. Just make it hello world. Okay. And nothing else. Is that syntactically okay? Get rid of that as well. Just make it hello world. And I'd be confident that it will work for you then. Now, the problem is, though, that you've no way of knowing which EC2 instance is serving back that hello world, but that's okay. Right. Really, the purpose of this lab is to ensure that you what's called bootstrap your AWS account. And I talk about that in this part here. Okay. So I think you should work your way through the lab. And if you get that 502 gateway error at the very end of the lab, then don't be concerned about it. I'm hoping you won't get it if you make the change that I just showed you there to the code. But if you do get it, it doesn't mean that there's something wrong with your AWS account or there's something wrong with your CDK framework installation. You can be guaranteed that if you do get that 502 error, you can be guaranteed that your AWS account is configured properly, your CDK framework is working properly. There is just a slight bug in the code that I gave you in the stack file that I gave you, and you needn't worry about it. But I do need everybody does need to work through this lab, and I'd be interested in getting responses back from you as to whether it worked or not. Right. Um, that's our intro to the CDK framework, but we are going to be using this framework right throughout this uh, module. The next topic I want to talk about is the serverless architecture. And again, we're going to be using the CDK framework right throughout this section as well. I'll just pause for a second in case, in the odd uh, possibility that there may be a question from somebody. No? Okay. Let's start off this topic. Serverless architecture. So I'm going to walk my way through these slides, and I'm not going to get through all of them for sure, which will mean that you will be able to start this lab, but you won't be able to finish it this week, and that's okay as well. So let's bring up these slides here. We're going to talk about serverless in general initially, just one or two slides on what we mean by serverless when we talk about cloud uh, platforms. But the majority of time will be spent talking about AWS's serverless services. Yeah. So the first thing to say when we hear the word serverless, it seems to indicate that there are no servers involved, but that is not what it means. Serverless means that you, as a developer, you don't have to worry about provisioning servers in order to run your applications, your traditional kind of applications. When we talk about applications, prior to our discussion on the CDK framework, when we talk about applications, we're talking about functionality. So, for example, in the previous semester, you would all have developed a web API. That web API would be deployed onto the server side. So we need some place, some platform in which to run our web API. Now, if we did not have serverless available to us, then we would have to create an EC2 instance and deploy our web API onto that EC2 instance. Yeah, sitting on top of Node in your case anyway. But with the introduction of this serverless model, and sorry to go back to that previous example, so you would have been responsible for creating the EC2 instance, setting it up, downloading your web API onto it, and getting it up and running, and then maintaining that EC2 instance. Make sure it was always running. If it did go down for whatever reason, you'd have to reboot it and debug it and all of that kind of stuff. Uh, Whatever operating system was actually installed on the EC2 instance, you would have to make sure that it was kept up to date by various security patches. All of that responsibility fell on you, the developer. But with the serverless model, all of those issues are taken care of by the cloud provider themselves, AWS in our case. It's not that there isn't any EC2 instance running in the background. There is, or something maybe similar to it, but you don't have to worry about the provisioning of it. You don't have to worry about the maintenance of it and all of those issues. So serverless does not mean that there aren't any servers. What it means is that you don't have to concern yourself with these issues here. If serverless never came about as a platform, then you as a developer, these are some of the issues that you would have to be dealing with. Okay. But, and you can read through those yourselves. They're both at the hardware kind of level and at the operating system level. With serverless, though, it means we get all of these benefits. So we've no servers now to provision. We don't have to create EC2 instances ourselves. We don't have to manage them. I've just been talking about that. The whole area of scalability is taken care of for us. And scalability, that actually relates back to the lab, the CDK lab. Sorry now if I might just flick back to that. In the CDK lab, of course, the CDK lab, this lab here now, is not based on the serverless model. It's based on the old traditional model, the server-oriented one, if you might call it that, where, we decided we need to have two EC2 instances running our web API, and we need to have an application load balancer in front of those. And the application load balancer takes care of directing or balancing the load between these two EC2 instances. So these now are running our custom web API. So scalability was actually part of this whole piece of infrastructure, and we had to create all of this infrastructure. But with the serverless model, you don't have to worry about that. It will take care of scaling up the infrastructure when there is a high level of uh, demand on it and scaling it down when that demand um, decreases. There's no upfront cost. I've already told you a couple of times that when you create an EC2 instance, even if it's sitting there idle, you're still paying for it. But in the serverless world, you only pay for the amount of usage that the infrastructure uh, is dealing with. So you kind of pay kind of per request almost. Um, in relation to availability and fault tolerance, that's also taken care of automatically for us. One of the problems with the availability back in the pre-serverless world was just because we have, again, if I go back to here, just because we've got two EC2 instances running here, okay, that deals with scalability. But if these two EC2 instances are running in the same availability zone, and that availability zone is inaccessible temporarily from a networking point of view, then suddenly our application, our web API, is temporarily not available. That's clearly not satisfactory. So we would have to actually make copies of our EC2 instances in the other availability zones within whatever region we're deploying our application to. So these were all the kind of headaches that you had to deal with in the pre-serverless world. In the serverless world, though, AWS will take care of ensuring that your application, web API in our case, is always available. There are techniques for achieving that. So we get these benefits, which you can read over yourselves. This is a nice graphic that I saw, and it kind of illustrates how the developers, how the world of the developer has kind of changed over time. Like way back initially, the developer had to worry about everything. They had to be concerned with buying the hardware, which is buying your server machines, installing the operating system on that hardware, maintaining the operating systems, keeping them up to date, etc., and then deploying your application on top of the operating system. When the virtual machine era came about, well, we no longer, as developers, had to worry about the hardware. We still had to worry about the operating system, though, and making sure that that was being patched and maintained and kept up to date. The next era was the containerized era. We did a lot on containers in the previous semester, and we know a lot about the advantage of the containerized model. Now we're in the serverless model, and in the serverless model, as a developer, you just write your functionality. You don't worry about anything lower down the stack than that, within reason, I guess. But okay, so the developer's focus has changed over time. Or the majority of their focus has changed over time. Now, that's kind of a very high level overview of this whole notion of serverless. If we focus in on AWS specifically now and see what does it provide to us, the developer, if we want to develop our functionality and run it on a serverless platform rather than a traditional server-oriented platform. So on the left here, I'm listing some of the AWS services, AWS serverless services. So the one that you've probably all heard about is AWS Lambda, and that's what we categorize as its compute service. So in a sense, AWS Lambda is the alternative to EC2. Okay, DynamoDB if we want to have a database as part of our application, then there are a number of serverless database services that AWS provides. One of them is DynamoDB, which we will look at. It is a non-relational database architecture, though. You can have serverless relational uh, databases as well. We won't in this module. AWS Cognito is a serverless service for managing user accounts. We will look at that. API Gateway is a service for creating REST APIs, HTTP APIs. We'll certainly look at that. So that will link directly back to all that you've learned about RESTful web APIs from the web app dev module for last year. But in our case, we're actually going to be deploying it up into the cloud, and we won't need to provision any low-level kind of resources in order to get it running. S3 is essentially kind of a file storage service, but it's also classified as serverless. And there are other ones as well. SNS and SQS we will look at the back end of this module. Very important message-oriented services, and so on and so forth. On the right, what I'm showing you is kind of a classic example of a serverless application deployed onto the AWS platform, right? And by classic, I mean, let's say it's well, not let's say it is, it's a classic kind of um, structure, infrastructure for a web application, where a web application is comprised of a front-end client, let's say a React app, and a back-end web API. So what we have here are, we've got the Lambda service operating here. This is where we actually have our functionality, our endpoints, okay? And you may have a number, well, not may, you definitely will have a number of Lambdas running, okay? And each Lambda implements a particular piece of functionality. Those Lambdas, many of them will be talking to our database. In our case, it's a DynamoDB database that we're representing here, which is one of our serverless services over here. Okay, so the Lambdas will be talking to DynamoDB. Now, these Lambdas aren't accessible directly from your browser, if you like. They're only accessible via this piece of kind of middleware, which is called an API gateway, which I mentioned over here. So our React app, if we stick with that, our React app will be sending requests to the API gateway, and the API gateway will be routing those requests to one of these Lambdas. And the routing will be based on the path name that it received in the request. Okay, so that's kind of the flow of execution that will be going on here. We will be developing this over the next couple of weeks. On the left, well, let's say on the right first, actually. On the right here is I'm representing the Cognito service. The Cognito service will take care of user logins and user authorization and authentication. So your React app its login page will be communicating with this Cognito service, and the Cognito service will validate your credentials, username and password, and typically return a token. In our case, it will be a JWT token, and that token then will be used for subsequent requests that you send to the API gateway as a way of authenticating with the gateway in order to give you access to the Lambdas. Here I'm using the S3 service, and the S3 service in this scenario is actually used to host our React app. Okay, so when the user browses to the homepage of our React app, that kind of request will eventually be directed at this web app that has been deployed onto the S3 service. You can actually create an S3 bucket and configure it so that it is the host for a front-end application. And so it will serve the React app back to the user's browser, and then subsequent communication will be either to Cognito or to API Gateway. So what we will concentrate on this module, though, is we won't really be looking at the front end part. We'll be focused on the web API part, all of this encompassing all of that there. And it will take us, I guess, maybe 3 weeks, maybe a little bit more to get through all of that. So that's kind of the big picture objective. And so we just need to step our way through some of the main AWS serverless services, and certainly top of that list is the Lambda service. So this is the service that we use to deploy our actual functionality. So what is the AWS Lambda service? Well, if you don't know by now, Lambda is, I'm saying, well, okay, it's event driven. I have to explain that, but it's the serverless compute platform provided by AWS. So serverless, we know what that means now. Compute means that we can actually upload code to the Lambda service, and that code will be executed by the Lambda service whenever it's triggered. Now, how does it get triggered? And the code here now I'm talking about is your kind of traditional functionality code. I'm not talking about infrastructure code. We're already past that, if you like. How does that code get triggered? It gets triggered by an event. So that's why we're talking about event-driven here. Now, the simplest type of event that might trigger a piece of code is a HTTP request has been sent up to the AWS Lambda service, and the Lambda service will then execute our Lambda function. We talk about the Lambda service and a Lambda function. The Lambda function is the piece of code that we write, the functionality that we write, and it's implemented as a function. The Lambda service manages the execution of our Lambda functions. So it's event-driven anyway. That's the way we trigger the execution of our Lambda function. What the Lambda service also does, I'm saying here, is it automatically manages the computing resources that the Lambda function needs. And by that we mean it provisions some CPU, gives it some CPU power, some RAM memory, some network bandwidth. It takes care of managing those utilities for our Lambda function. Another way of kind of describing what this AWS Lambda service is all about is it's a way of us writing custom code, our Lambda function, and that code runs, I'm saying, in an ephemeral container. Now we know the notion of a container from last semester, and that our understanding is valid here. It's not a fully fledged Docker container, but it's some sort of variation on that. By ephemeral, we mean that the container instance is created. Our Lambda function code is loaded into that container. The code is executed. Our functionality is executed. And then the container is just trashed. It's thrown away. The next time our Lambda function needs to execute, then the same process happens. An instance of a container is created, our Lambda function is loaded into it, it's executed, and then it's thrown away again. So these containers are created and destroyed multiple times, essentially every time our function needs to run. So there's no, um, they don't persist over long periods of time. They can persist over a short period. If you've got two consecutive or a number of consecutive events targeting our Lambda function, then it wouldn't make sense to create the container and destroy it and recreate it and destroy it multiple times. You could just uh, hold on to the container. Uh, but it's the AWS Lambda service that manages the creation and execution of the container for us. We don't have to worry about that. Now, I am using the word container here. When you read about the Lambda service, it uses the term a micro virtual machine or micro VM. So maybe we could substitute that for container here. We don't want to be confusing it with Docker containers. Although a micro VM, a micro virtual machine, and a Docker container are not that different at one level. You consider them in the same kind of uh, uh, ballpark kind of area. Another way of talking about AWS Lambda service is its function as a service. We're familiar with these acronyms when we talk about the cloud and all, infrastructure as a service, platform as a service, software as a service. Well, there is this acronym FAS, function as a service, and that's really what the Lambda service is. That's how you might categorize it. So this is, again, I've kind of talked about this, but this is a visual representation of the kind of the runtime model for this AWS Lambda service. So on the left, you have some source for your event, and the source of the event uh, could be anything, right? We have to configure it, of course. This symbol here is representing my Lambda function, or this image, this icon is representing my Lambda function. This image here is representing the Lambda service. And so the flow is the event that's targeting my Lambda function, that event occurs. We needn't worry about how it occurs for now, but it occurs anyway. And the event is received by the Lambda service. And the Lambda service then will essentially uh, kick off that process of creating a micro VM instance, loading your Lambda function into that micro VM instance, invoking the Lambda function, and passing it the event that occurred. And passes the event as just a parameter to the Lambda function, as we'll see. The Lambda function executes, and when it's finished, the Lambda service will now destroy the micro VM instance. Later on, another similar event occurs, and the same process happens all over again. The Lambda service creates a micro VM. We could think of the micro VM as a kind of a box around it's a container, to use that word, for our Lambda function. But it creates an instance of the micro VM, and the configuration of this micro VM is something that we have to describe in our infrastructure code, admittedly. But it creates the instance anyway. It then loads our function, our custom function, into that micro VM, and then it invokes the function. The Lambda service invokes the function and passes in the event object, and it processes the event. And this happens over and over and over again. Yep. And that's what I'm talking about down here. So we have the event source, which is this bit over here, which I haven't talked a whole lot about, but we certainly will talk a lot about it as we walk our way through it. So the event source might be a HTTP request. That's a simplest example. The event might be something a little bit more sophisticated. It might actually be a change has happened in a database. So if this here was an actual database and a new record has been written to the database, that actually, the database might be the source of the event. So it's actually going to be telling the Lambda service about the change that has occurred, and it describes that change in the form of an event construct or an event object, let's say, and that kicks off this whole process. Or the event could be, if this was an S3 bucket and a new file was uploaded to the bucket, and the S3 service is now creating the event and passing it to the Lambda service. Now, we would have to, in our infrastructure code, we would have to describe the relationship between the S3 bucket and the triggering of our Lambda. That is something we have to describe at the infrastructure level. And we will see that um, uh, later on. So that's the event source, the Lambda function itself, this bit over here, that's the functionality that we write, and we can write it in any language we want. The Lambda function, in terms of what it does, it can communicate with any other service. It could be talking to, simplest example might be it's talking to the DynamoDB service. But it can communicate with any other service, and we will see lots of examples of that as we work our way through. Lambda service, okay, kind of made a lot of these points, but these are again some general characteristics I'm saying about the Lambda service, or what the Lambda service does first. I'm saying it manages auto scaling. If I just go back, let's supposing you've got a high volume of these events occurring concurrently. Now, what happens in that case, if I just clear my screen a little bit, what happens in that case is the Lambda service will create a number of these micro VMs just on the, dynamically. And each micro VM will be loaded with your function, and then it will take care of load balancing this high volume of concurrent events, load balancing them across the various micro VMs. So that's classic kind of scalability. It scales up the number of processing units that we need to handle the events. So auto scaling is we get for free. We pay for it, of course, but the actual mechanics of it is taken care of for us. Load balancing is done by the Lambda service. Just explaining that. OS management, OS maintenance. What I mean by that is, again, if I go back to here, each of these micro VMs, obviously they will have to have an operating system installed on each of them. And we'd want to ensure that the version of the operating system is as up to date as we want it to be. And we can specify in our infrastructure code what particular OS kind of platform we want. But the Lambda servers will make sure that whatever version of the operating system, it has all of the various security patches applied to it, takes care of that kind of maintenance side automatically. Back to here. So that's fine. Security isolation, where I was showing you there on the previous slide, a number of micro VMs. Those micro VMs are completely independent of one another. So they're isolated from each other. And as well, of course, again, I'm switching back and forth now, but if I go back to here, of course, this Lambda service is going to be dealing with events not just related to our application, but related to other applications of other users. And we'd want to be fairly confident that the various micro VMs that it is instantiating, that they're all completely isolated and secured from one another. Even though some of them might be running on the same physical hardware, because we can control which particular servers are micro VMs are going to be running on. But if they are running on the same hardware, if micro VMs that have been created for me are running on the same physical hardware as micro VMs that have been created for you, then we'd want to be fairly confident that those micro VMs cannot actually communicate with one another. There are no security holes in that sense. And the Lambda service will guarantee that for us. I've talked about the utilities, make sure that each micro VM has the enough compute power, RAM, and network bandwidth. It takes care of managing all of that for each micro VM. On the right, kind of made these points already. So as a developer, you're now dealing with functions as the unit of scalability and deployment. In the days of EC2, scalability was at kind of at the application level, where now it's down at the function level. Function as unit of deployment, yeah, that's okay. Uh, stateless, the stateless nature of it. What I mean by that is, again, if we go back to here, and again, let's just do a cleanup. So we have our micro VM that has been created, event occurs, micro VM has been spun up, our function has loaded into it, and it executes. If another event, similar event occurs a couple of minutes later, then it goes through this process again. So there's no sort of memory. There's no memory of the previous event. Okay. Hence, we say that this whole model is stateless. We can't have any kind of referencing back to the previous event or the history of the events. If we want something like that, then we've got to take a completely different approach. So these micro VMs, this model is stateless. It doesn't have any memory of previous executions, if you like. There is a limit, I'm saying here, there's a limit to how long a micro VM can uh, be executing for, or in other words, there's a limit to the amount of processing that can be done by a Lambda function. I think the upper limit is 15 minutes. So if you've got very heavy processing requirements, then you may not. One approach would be to split it up into multiple lambdas, or you may even have to revert back to the more pre-serverless kind of model. Runs on demand, that's okay. You pay per execution, and I've kind of mentioned that already. You do not pay front up costs, okay. Now, from a developer's perspective, there's two things that we have to do. We have to write our infrastructure code, and we have to write our Lambda functions. And I'm showing you here what I'm calling the anatomy of a Lambda function. Okay, you've got some imports perhaps at the top. But there are really two parts to your Lambda function. There is what we call the initialization code and the handler code. The handler code, that is really our Lambda function. That's where we have our processing going on, if you like. The initialization code, typically what goes on there is if you need to create references or clients for other services that our handler will be using. The simplest example would be supposing this handler needs to communicate with a database. Let's say it's a DynamoDB database. Now, getting a connection to that database, that code goes into the initialization part. You can put it down here, but it's considered very bad programming or bad practice. So here is where you create your connections with external services like DynamoDB or SQS or S3. You make the connection here, and then you use the connections down within your handler to actually communicate with those external services. Yep. So we've got the handler itself is the actual Lambda function. The event object, well, when we look at the signature of these handlers, the first parameter, there's always actually only two parameters. The first parameter is the event object that triggered the execution of our Lambda function. And we will be looking at and it's in the case of TypeScript, that will just be a JSON object. And there'll be some really interesting or important information inside that JSON object. And we'll explore the internals of it as we work our way through this. The context is the second parameter. I don't think we ever need to use that, but the context would give you access to the micro VM itself if you needed to do that, which we never do. And the initialization code, I've talked about that. So that's the anatomy of a Lambda function. Now, in terms of configuring a Lambda function, there are a couple of things, but one of the parts of the configuration um, is how much kind of compute power do you need for this Lambda function? And the way we actually specify that is not obvious, right? And it is as a result of a kind of conscious decision that the AWS Lambda designers, uh, the decision that they made, which was that the only way we control the compute power for our Lambda function is via the amount of RAM that we want to have made available to our Lambda. Okay, so that's what I'm saying here, that the Lambda service provides a memory control or a memory configuration, a RAM configuration. So you just specify how much RAM you think your function will need, and you can fine tune that. Now, we won't be looking at that, to be honest, but in production environment, you certainly would. And the more RAM that you request to have allocated to your Lambda function, that will uh, that will control how much CPU power is available to it and also how much network bandwidth is available to it. And the AWS Lambda service takes care of controlling the CPU power, in other words, the percentage or number of virtual CPUs that are associated with your Lambda function. And it takes care of that. You can't control that. Well, you can control it, but you control it by virtue of the amount of RAM that you want to have associated with your Lambda function. And I've got some simple kind of data here, right? So the RAM, the lowest amount of RAM is 128 megabytes, and the highest is up to 3 gigabytes of RAM. And it goes in increments of 64 megs. I don't think we ever need to go any higher than 128 in our case. But clearly, if your Lambda function there's quite a lot of processing, heavy processing, then you will need to bump up the amount of RAM. Otherwise, the Lambda function is just going to crash, and that's an indicator that it's running out of RAM, and you need to reconfigure it. And so the more RAM, as I said, the more RAM you add, that controls the amount of virtual CPU that's credits that are allocated to your function. And there are just some simple examples here that you can look at yourself. Now, as well as configuring the RAM for your Lambda function, the other thing you do need to do is to indicate a timeout setting for it. And the timeout setting indicates the amount of time you expect your Lambda function will need before it completes its processing. And if it exceeds or consumes all of that timeout period, then automatically the Lambda service will stop the virtual machine and it will return an exception and it will throw away the micro VM. So the timeout kind of controls the upper limit for the amount of time that your Lambda function will need to complete its processing. And clearly that is something that you need to tune um, and work out over time through a lot of testing. Now, equally, we're not going to be looking at that aspect of uh, Lambda function um, generation, but it is an important configuration setting. The default is saying here 3 seconds. And in most of our cases, we won't need anything more than 3 seconds for our Lambda function to complete its processing. But as I said, if you set it to, let's say, 10 seconds, and then your Lambda function is still executing after those 10 seconds, then the Lambda service steps in, it stops the execution of your Lambda function, it returns an exception back to the event source, and it thrashes the micro VM. And as usual, I get the demo, but I won't actually have time. I'm at 2 o'clock. Maybe I'll just have a couple of minutes just to explain the short demo. So in the demo, I want to use the CDK to provision a simple hello world Lambda function that's written in TypeScript. And then I want to invoke that Lambda function. I want to invoke it actually from the command line using the AWS CLI. So I'll just pull in the demo anyway, whether we get to run it or not. Let's see. And now we're back to CDK again. This is a CDK project. Here's my CDK stack. And here we go again. I've called the stack that. And this is how we request the provisioning of a Lambda function. And provisioning here simply means that we want to upload the Lambda function itself, and it's just going to sit there, right? The Lambda function is actually here, which we'll look at in a second in a separate folder. So this is some functionality, but all I'm looking at here is the infrastructure. So we need to provision a Lambda function. And again, if we look at the provisioning, okay, we've got a nice convenience class available to us called the Node.js function. This is another example. Node.js function is another example of a CDK L2 construct. The parameters are the same kind of idea as before. We want to associate the Lambda function with the current stack. This is just an ID or a name that we want to give to the custom name that we want to give to the Lambda function. And the rest then is our configuration of our Lambda function. In the configuration, though I might have slightly misled you when I was talking about configuration there a moment ago, but it turns out that we need to do a little bit more than what I was indicating on the slides. As in, we need to, let's see, here we're specifying the runtime environment that is going to be available within the micro VM. And so you can see I want to have Node version 22 installed on the micro VM for me. This one here is actually specifying the type of hardware that I want the micro VM to run on. Now, there certainly isn't any need for me to, I've just put it in here for illustration purposes, but I could have left this entire line out and let the Lambda service assume the default, whatever the default architecture is. But just for illustration, I am showing you that you can control the nature of the kind of hardware that the micro VM is running on. The runtime I've just talked about here, I'm just referring to the file that contains the actual Lambda function itself, which in my case is this file here. We'll look at it in a second. Here I'm specifying a timeout, which I was talking about. Now I've set the timeout to 10 seconds, but that's certainly overdoing it. I could have left the default there, but again, it's for illustration purposes. And I'm also being specific about the RAM that I want, but 128 is the default anyway, so I could have also left that line out, but this is how you control it. And the Lambda function uh, is this, right? Now, there's no initialization code, so that's why this part is empty. This is the actual handler itself, my Lambda function. The arguments are the event object, although it's not really useful in this case, and the context. And all my Lambda function does is it does a console log. Now we do need to see where does that console log actually go to. And uh, Lambda functions are invoked over a network. So they do have to respond back at the kind of HTTP level. And this is the kind of HTTP response back to whatever triggered my Lambda function. So it's a standard status, HTTP status 22 with an accompanying kind of message. Yeah. And CDK deploy, pushing it now a little bit, but if you bear with me, I'm going to do a CDK deploy. Sorry, now. CDK deploy. Same sequence happens. Oh dear, why is it doing that? Um, do I have errors in my code? I do. Oh, let's quickly undo that. Same process is happening now behind the scenes, and that CDK framework is creating the CloudFormation template. And as it works its way through, it should be quite quick in this case. If I quickly just look at the Lambda service, I'm logged out. Serves me right. Am I logged out? Well, maybe I'm not, sorry. So it doesn't look like I have any Lambda functions, but maybe that's because should be a Lambda there. Let me do a refresh. I know. Okay. There's my Lambda function that has been provisioned, and I'm really overdoing now. So I'll stop at this stage and I'll pick up the story from here next week, which really means, in terms of the lab, in terms of the lab, uh, you could just have a go at the very first part of the lab. That's as much as I would expect you to achieve. Either way, um, I'll let it G. Okay, sorry for going over time now. I'll stop at this stage, but I will pause in case there anybody has a question. I'm happy to answer questions. The rest of you are free to leave if you want to leave. No. Okay. Thanks for hanging on if you are still there. And the labs now are um, I do attend the labs tomorrow morning. People can still work on them online if they want to, but I will be physically in the lab rooms that are scheduled for us. If some people maybe prefer to ask questions kind of face to face rather than over Zoom. So I will be there, and you're welcome to turn up at your allocated hours. Okay, thanks, and I'll talk to you later. Bye bye.